Welcome back to the video. Today we're doing Leetcode 2095. It's going to be deleting the middle node of a linked list. So here we're giving a linked list, and then we have to find the middle node, so these three on the left, and then these three on the right, and then we have to remove that node from the linked list. And that's pretty much there is to it. So let's actually start coding it up. So we're going to be doing this in Python. There's actually two ways to do it. You could do it two pointers, or you could find however long the list is and divide it by 2. And then delete the node. So first we're going to do two pointers. So we could say if head, this is the first condition, if the head itself is null, or like the head.next is null, we just return like pretty much nothing. If head is none, or head.next is none, we could just return none. So that's all that is. And then this is the two pointer method. So we could have two pointers called slow. So we're gonna have one pointer. It's gonna move over 1 by 1 by 1 by 1, and then the next pointer is gonna move over 2, and then by 2, and then by 2. Once the fast pointer that moves over 2 is at the end, the slow pointer should be at the middle node. So let's actually code that. We could say slow and fast. We're just defining two pointers. We could actually do it like this. We could slow. We could do it like this so you understand. Slow equals head, which is what we're passed in to like the Python function, and then we could say fast equals head. So now we're just declaring two pointers equal to the head itself. So they're pointing to head. And then we could call the other one previous slow. Oh, that's too long, so I don't have to type this a lot. We'll call it pre-slow, whatever. Since the slow pointer is going to get you to the middle, in a linked list, we need like the previous node, and then we're going to skip over the node we want to delete to the next node. So that's why we have something called previous slow, pretty much. And now let's assign it to something. We'll set that equal to none, which is just pretty much null in Python. So now we have that. Now we can use a while loop. We could say while fast and fast.next. So the fast pointer is going to be the one that's going to jump over two nodes. Once it's at the end, the slow pointer will be at in the middle. So we could say, well, fast and fast.next is not none, not none. I'm used to programming in Java, so I'm used to like null. So while the fast pointer, well, until it gets to the end, we're gonna keep incrementing slow and fast. So slow goes by 1, and then fast goes by 2. And then we called it a prev underscore slow. We're gonna set that equal to slow, because by the end, slow is gonna be at the middle, but we need the prev slow to be in like the middle -1 or be at this node. But once we're done with the while loop, slow is going to be in the middle. So that's why we're setting pre-slow before we increment slow to the next node equal to the previous node, if that makes any sense. And then we could move slow by saying slow equals slow.next. Here's what we're doing. Here's where we're moving the node. So before we move it, we're assigning what was before in slow to previous slow. So that's going to get us one before the middle node. And then we could say fast equals fast dot next dot next. So this is moving over 2. And then we could say prev, you call the previous slope, this stands for that, dot next. So imagine we're looking at this linked list right here. So now we're here at the 4. Because once fast or fast.next equals none, slow should be in middle. But remember, we set pre-slow equal to before slow was equal to middle. So now previous slow is right here at the number 4 or index number 2. So we're saying pre-slow dot next equals to prev underscore slow dot next. So what this means is normally this is pre-slow right here. The next would be 7, but when we say dot next, we're kind of like imagine us drawing a line over number 7 and we go straight to 1. And then we could return head because slow is pointing to head, so therefore pre-slow is also pointing to slow, which is pointing to head, so we could just return head. And if I didn't misspell anything, this should be it. That's accepted, so now we can just submit that. Cool. And then I might do the other one too. Here, let's see if we could do the one where instead of 2 pointers, we could find the length of the list and then divide it by 2. So we could pretty much do the same thing. Let's actually, we'd keep that base case right there. And then we could say current equals the head, and then we'll set count equals to 0. So here, we're going to iterate through the loop, through the list, and then for each node, we're going to increment count. And once count's incremented, we're going to divide count by 2. And then once we get like the middle one, they're going to do the node before, and then pretty much do the same thing, skip over that node. So we could do that. So we could say, while current is not none, so while current is not null, we want to keep going. That means the current node is not going to be null, so we can increment count plus equals to 1 because there's another node, and then we can move current along, which say current equals current.next. So this is where just getting how like we're pretty much, if there's a node, we're adding it to count so we could see how many total nodes there are, so we could divide it by 2. Okay, so now we have that. Now we can have a variable called middle. So that equal to count, because now we count all the nodes. The // integer division, and then divide that by 2. And then we could say current equals the head again to reset it. And then we could use a for loop for x in range. We'll say middle minus 1 because middle gets us to the middle node. We want to do minus 1, so we can get to that node right there. We could say middle minus 1. We could say current equals to current.next. Let me actually indent that so we don't get an error. And then we could say pretty much the same thing as the other one. We're going to say current.next equals current.next.next. So now we're right here at the 4. We say current.next. Current.next will normally point to the 7, but when we say current.next.next, current.next equals to current.next.next. So this is going to point us to this one. So all we're doing here, we're getting count how many nodes there are, and then we're storing that inside of count. And then we're incrementing it until current is null. Once current is null, we're done. That's how we're getting the count. And then we're setting middle equal to count divided by 2 because we need the middle node. So middle stores the middle node. Remember, we don't want the middle node. We need the node before that. So now we're just resetting current equal to head. And then we get incremented to like middle minus 1. So we get here. And then we just advance the current node by setting current equal to current.next. And then current.next, we're right here. Current.next equals current.next.next. Normally current.next would be 7. Current.next.next is just a 1, and we're deleting that node. And then we could just return head. And then that should be it. Personally, I like the two pointers. Forgot the 2 dots. I like the 2-pointer solution, but this one works as well. Guess I ran out of runs, but we could submit it. And if we did everything correct, yeah, it works. It's normally slow, by the way. Let's submit it again. Okay, I got faster. Let's submit it again. It was at 16. Now it's, guess I ran out of submits. I use Leetcode free because I'm not about to pay for all that. Submit again. We're at 27%. I think 2-pointer was faster, but this is another way you can do it. 31%. So it just keeps getting better and better. That's funny. But yeah, if it's helped you in any way, please leave a like and subscribe.